basically, the real thing that's happening here is you have on the left side, you have a depth estimation, actually. I faded it into the real photo. So it's a little bit complex. I'll discuss that in a moment. But the short story is that none of our current systems would be able to properly catch a 3D model of this kind of garden, not even close. They fall really hard on their face when you hand them something like this. So for a lot of reasons, there's so much. Plants are so complicated. They're one of the most complicated things in the world. You know, if we're going to compare it to other naturally or artificially occurring objects. I personally like that. I think it's forced, you know, the necessity to develop incredible AI. But okay, so this talk is switching gears, and it is much more about plants. I'm aware that the last one was just really mostly about 3D reconstruction and 3D modeling. Now we're going to switch gears, and I wanted to say this, even if to be humble and to say, please don't eat me alive, because you know, I'm moving from my steady ground of spending the past 5 years on 3D reconstruction to getting into AI for horticulture, plant recommendations, landscape recommendations. I'm not an expert, and it's not my professional field. I would love to develop a useful tool for those who are, and as well as for regular people. But the point is, this whole gathering is to, you know, bring together the right people. And I was telling Howard, probably all of us have some level of imposter syndrome or something, because there's just such an interdisciplinary, you know, gathering of people and you know, visions here. So anyways, I just wanted to encourage everyone to feel like everyone has something to offer here, basically. And so anyways, this is maybe the lesser.
Actually, I have to go talk myself. So.
Sure.
But I'm from computer science.
Oh, you're computer science. Oh, okay. Nice. Well, I'm computer science too. So
many
I like it. All right. Well, we can.
I'm trying to find this place. There are many buildings here.
Who's the next one? I'll do it, Roger.
Sorry.
No, you're great. You're great. Okay, so right. So basically, you know, with all of that, yeah, I think self-deprecation in place. You know, the ambition is as large as it could be. I would say it's basically, you know, we want to develop AI models to basically assist with selecting and placing plants anywhere in the world. And I really think of that as the process of creating a garden, basically. You know, there's a lot more that goes into it, but that's kind of the essence of how I'm thinking of it. So I'm going to just describe 4 things. I'll only end up discussing in detail 2 of them, but I wanted to make very clear what the next steps look like. So a lot of it is going to be work that we've already done. And then there's going to be pointing to work that we hope to do. So basically, the first thing is, you know, if you're going to have an AI recommender system for plants, it had better have seen a lot of plants in a lot of locations and genuinely have good data to ground that thing. So it actually is better than, you know, so it's superhuman in its intelligence of plants. And that's something that we've emphasized as the starting foundation for this new project that we've been going after. So collecting huge amounts of data on climates and microclimates preferred by species, basically. And allowing us to use that to right away, given your GPS coordinate, automatically filter out species that won't grow well, I think is the most important thing, actually. People need to stop killing plants. I think that's, you know, I think it's about time. You know, we've all
put the nurseries out of business.
I think the opposite, I think, is true. I think it will increase consumer confidence dramatically, because people will feel more confident their investment is going to grow. And I think it's going to grow the size of the market for, you know, home and garden retail and all that good stuff. And nurseries, the growers are going to make a lot of money, basically. So, okay, so that's the first thing. The second thing is basically, if you're going to collect all this data, you need a way to interpret it. Most of the data is definitely images. So we're building a computer vision system to understand plants and environments. I have to say that computer vision is the foundation for it, but there's other things. And so, you know, so basically, GPS coordinate is a part of it and so forth. But basically, you know, you're interested as well, not just in plants that grow outside near you, but in beautiful plants that, you know, if you were to hire your local landscape architect or the students from her workshop, who I'm sure develop beautiful gardens, you know, I think you're curious to know where they landed. You know, they were presented, and architects and garden designers, professional garden designers, are presented with a huge array of plant choices that they could make. And for many reasons, for artistic reasons, for all kinds of subjective reasons, for practical, functional, ecological reasons, they land on a much smaller subset of award-winning plants, you know? And so basically, we want to know what those plants are, and we want to know what they are anywhere in the world. So when someone opens up a phone, we want to be able to say, hey, in a 50 square mile radius around you, you know, we've detected that these are the 1,000 high-performing plants in, you know, the best gardens that we've seen around you. And so these are two things that we've made a lot of progress on, actually. The third thing is it's the next step, and actually I would just put it out there. If you have ideas, data sets, research, awareness of things that can help, please let us know. We're very interested. But basically, we need to get to a point where we train what we would describe as a scene understanding model, so that when you hold up your phone, it will take as much information as we can gather from the phone, from, you know, whatever we can gather from available data. But at the end of the day, we need to make specific inferences so we cannot put a shade-loving plant in the sun and vice versa. You know, we need, and that's just the start of the microclimate inferences, you know, knowing that this soil is more moist, all of these properties that Howard was describing, an expert would demand to properly assess. We are taking the step of saying, look, most people know none of this stuff. And by the way, most people are never going to have an interest in, you know, like walking through all of these things, but they might, you know, have an interest in having an AI system make them a little bit better than they otherwise would be. And of course, if you get more and more data, what I started to realize is that you can actually train an AI system just from seeing, like, you know, when a person holds up their phone and they see a big shaded tree, and we train another system to recognize species and we recognize a big shaded tree, we can bring that together in a hidden neural network, meaning it's not an explicit modeling task. We're not explicitly modeling shading, but the neural network would have seen it. And it would have started to learn that this species is more associated with the shaded tree. And so it's fascinating because, you know, you start to get to infer a lot of microclimate properties for free when you have huge data sets and you approach it as a computer vision problem. And that's what we're working on. But I'll be the first to say this thing's not perfect. It's just a MVP return. Yeah.
Are you taking into account like climate change at all?
I mean, this is a whole area for.
Yeah. And I just think about, it's not what I'm presenting on with GSI, but we have like a GSI plant list for like the different stormwater practices, like what types of plants are compatible with those types of practices. The dynamic moisture regimes and stuff.
I think I actually look at that.
Oh,
brainstorm
look at
on
that.
structure.
Okay.
Oh, look at that. The student asked the question. No, I included that for you actually, and I think you know, I do think it's pretty fascinating to you know, to start. So this is also a Howard thing because Howard loves the large language model perspective where you're talking with your garden designer AI, and you're starting to say something like, okay, let's develop the latest green stormwater infrastructure that we've got, you know, prototyped. Please include P2DOLF style gardens in that. And if we do this properly, we should get that. You're seeing DALL-E do stuff like this, right? So the key thing is to constrain these systems so that they're based on what we actually care about. And we have to do custom training to make this work. It's not going to happen with any of these open source, open AI bullshit. Sorry, just, you know, but basically the point is that we're willing and able to do this work. And I think we're excited to really put it into the real world, basically, and ground it and constrain these AI systems so they're only doing useful things as you would measure. Okay, but that's basically the high level. I really wanted to make sure I spent the most time on it because the last 2 points we're not going to spend a lot of time on actually. I don't think I get to it partially because I didn't get a chance to finish the presentation, but also I'm sure I'm talking about it. So what I will do is discuss the data sets and discuss the not just plant classifier, but plant intelligence systems. So basically, this is just a quick look at all of the locations where the data set that we're using has observed plants. There's 29 million photos of plants in this data set. All of them have GPS coordinates. And, you know, it's not evenly distributed around the world, but it sure as heck gets a lot of the world, you know, most of the populated world. So I think the great thing is that I actually started with just the United States, and then I used the classifier that I developed on some trees that I really love, and it didn't have it, because actually some of these plants are like exotic species that we introduced from other places that are not, you know, seen widely in the wild around you. So then I expanded data set collection to the entire world, basically. This is a quick look, just a random selection of species. So it's great to remind ourselves what we're talking about. And basically, also, how do these species taxon, classifications get made? These are from citizen scientists, but also from professional scientists who publish by naturalists. If 2 out of 3 people agree on it, it's considered a label. Nobody's saying that's perfect, but I think it's more likely to be correct than not, basically. So basically this all does come from, it's made accessible through this global biodiversity information facility. I'm loving this. Like, this thing is amazing. It's a intergovernmental, huge database of databases, really well designed technologically. You can hammer it. I hope they're not listening, but you can hammer it requesting data and they will give it to you. And basically, I've downloaded a lot of data from this. I'll present that in a second, but basically I wanted to point to an example species that randomly I clicked on and in the data set that we've been downloading. Let's look at that. It's in Florida. And also, those are all the observations of it. And basically, you can see that there's different data sets that it integrates as well. So we're mostly working with this iNaturalist research grade observations because they're all in the wild photos with GPS coordinates. But it's really super fascinating and relevant to point out that, first of all, I love Fairchild and I go there all the time in Miami, but University of Florida, Herbarium, and all kinds of UF data sets have been integrated into this global biodiversity information facility. So it's a real way to get the work out there. Yeah.
Have you come across any of these data sets, databases that account for below ground, like the roots? Oh.
It's probably there. That's the thing. I think these guys literally have like 10,000 data sets that they've integrated. So I would check it out if you're interested in it. I bet you might find something really fascinating. It seems to have everything that I wanted, but you guys will, I'm sure, find faults in it.
Who is the contributor for this data set? I mean, is people that use their phone tech photos upload?
That's the iNaturalist one, but then, like, for example, the Herbarium, which is right here, it's fascinating. Like, they have data all the way to 1975, probably well before that. So it's all kinds of researchers and citizen scientists, and you can choose your data set. You can filter. You can say, okay, I don't want these. I only want things with photos or whatever. It's really useful. And so so I was testing it and I said, okay, would this work as a way to basically really heavily constrain that we're not going to recommend species that we at least haven't seen growing somewhere outside within like a 50 square mile radius around you. Like, if we haven't seen these species growing outside, I'm not thrilled to put that to, tell someone, it's good luck. We've never seen that thing growing around here. So basically, this is a test, and around Miami, I live around here, right in the middle. And basically, I tested, hey, what are the most common species? It gives you a list of 8,000 species. So that's what shows up when you do this query, which, by the way, we're discussing automated, everyone getting access to these kinds of, querying your local species around you. Basically, this is funny, like, species, this seagrass. And I had to laugh. Yeah, like, we have a Fort Lauderdale boy back there too, actually. Like, you and I know, we've seen this everywhere in all the beaches. Yeah. And if you look at my query, it's including the entire coastline, which that seagrass has monopolized. So there absolutely is a lot of that. And then this is the sea grape, which also grows along the coast and salt tolerant and I would struggle to kill this plant, actually. It's not invasive, but it does extremely well. So anyways, so far so good. I was like, wow, if we put this into the hands of someone through an app, instantly it feels useful. It feels like you're already taking a step forward. But I said, okay, let's obviously do a lot more than that. So we went on a data set collection run, So we got ourselves some computers to collect lots and lots of data on the Turkish ground. Very cool. Okay. But basically, anyway, so we collected 2.6 million images from 33,000 species. These are the 33,000 most common species. When I did a query for all of the world's plants, as I was mentioning before, just to see all of the plants that we've got photos and GPS coordinates for, just collectively from everything that at least these guys have done, it was 100,000 plants, 104 to be So 33, the reason why we cut it off there is because basically there's only some of these observations, everything past 33,000, I think it was past 40,000, we've only got like 10 photos of. Like some of these plants are extremely rare, and they're not commercially produced. They're maybe endangered. I don't know what the story is of every one of the other 50,000 species is, but the point is that when you're looking for species that we've clearly seen, at least 15 times, that was my metric. I said, if we have seen this at least 15 times, I'll try and get an AI system to classify it. I would love for this to be, if not competitive with the best systems out there, better than the best systems out there, and certainly used for the case that we're focused on, which is helping someone to design a garden. We'll talk about that. So, oh, by the way, this is my favorite flower. This is the Delix regia. I was gonna ask if anyone knew, but I released the details. Okay, so that's one data set. Think of that as a data set that we have. There's another data set that we said would really help us. And this is much more moving into landscape architected designs. I think, yeah.
I haven't moved the reference, maybe you can remove the bar, so like.
Oh,
the beautiful
is it
photo,
better?
Center
Yeah,
more,
how do I do that?
hit more, and no, yeah, click on the more, like
Nice.
where you were and go to, yeah, went down,
This one?
yeah.
Nice.
Like when I enjoy this photo.
Good. It's, fantastic. Okay, I agree. That was probably one too. So yeah, so this is the second data set. And as I said, I want to I think I want to say something first. So basically, I know that we're in a space where AI is basically crawling all kinds of data and people's designs, and it's a question of whether AI is good or bad. It could be both, obviously. And all I'm trying to say here is that I definitely think if we can capture a lot of the skills and tastes of what landscape architects would do and scale that to more and more people, I think the net positive is really good. And I still think as well, we can build a tool for landscape architects that improves what they do as well. Definitely want to say that, because I think a lot of times there's all kinds of data that I probably put out there that is being used to train something against me or whatever. And I'm just like, yeah, it's a strange world with AI, and I'm just acknowledging that. But anyways, we're very focused on doing, we want to work on the right stuff for the right people. Okay, so we've basically collected 100,000, well over 100,000 actually, garden photos from the biggest 250 cities in the United States. Gainesville is included actually, so I kind of made sure to hit that metric. Gainesville comes in at like 150 or something. But basically, I had to build an AI system just to detect if there's a beautiful garden in the photo, because a lot of it was from different data sets. Yeah, so I'll just show you a cool photos here. So take you around the US for a nice little journey of garden touring, which it was fascinating to see all of this coming in and looking at gardens from all over the country, basically. Something that I think it's just the case. I didn't have room to collect every property, so we just focused on more expensive properties. I do think that over time it would be great if we had awareness of like every good garden that's ever been designed, and then we build that into an AI system. So this is just cool stuff. It's pretty houses and pretty. So, but basically, yeah, that's the data set we have, and I just wanted to make the point, which is that we're going to take the data for understanding species from photos, knowing the labeled photos of which species to classify, and run it on all of these garden photos. Because then what we can get out of that is a list of species selected by whoever designed these gardens. And I know there's a lot of people, there's literally hundreds and hundreds and hundreds of people. So yeah, anyways, I think it's really fantastic to put that intelligence into the hands of the retail customer. Yeah.
Have you tried like any method of having the AI assign like a beauty value to the garden?
Yes, the short answer is that I think from what I've seen, I mentioned that I had to train a system to detect if there's gardens. And I implicitly, if it was like a really ugly, I was like, oh, there's a plant there. And I'm like, there's nothing going on here, And I was like, tell it that's not a garden. And so it's fascinating because you can see, and I'll describe it. It's actually super valuable to discuss the next step, which is exactly what we're discussing here. The vision AI behind all of what I'm getting into is super intelligent and open source. And basically, my point is that Yeah, with a little bit of fine tuning of this really big model, which I'll describe shortly, you're able to have it be a beauty detector or whatever. So I'm basically, I probably can build a system to score it. And you spend about an hour, 2 hours, or whatever it is as a human labeling your data. And you toss it into the AI system and you're like, I told you 300 photos of beautiful gardens, 300 ugly gardens. Now score them or something like this, score my 2 million or whatever photos, And yeah, I think the answer is AI can see beauty if you teach it what beauty is. Yeah.
But the beauties can be very objective also.
Yeah.
Right?
Yeah, so maybe we need multiple human reviewers to label it together. It's a good point. I mean, Howard made some points.
How to set up the standard is very hard.
Yeah,
But you
for
can't-
now,
you
I'm the
can't-
god of the AI. No,
Yeah.
I think it's a useful thing to mention that, because I think, having more people involved in this stuff.
You can include the basic elements and principles of design, like color, texture, form, to help you inform what beauty is or not.
That makes sense too. Yeah, I mean, you can train little pieces of AI to do easy tasks. Beauty, yeah, maybe recognition of beauty is a harder task. A lot of times it will pick up on these things in the pixels. So that's part of the reason why I trust it, is because it ends up inferring the things that we think of as color, texture, shape, distribution, and so forth. So I would give this beauty photo 100% in my book. I'm pretty sure this is, yeah, I think I've been here. I think this is an adult garden in his private yard of Pomelo. And, I'm really curious if we can take AI and have it look at a photo like this and pick out every single species that's there, at least with some accuracy. It's okay if it's not perfect. We shouldn't obsess about that from day one. But basically, in this case, you can see this is an open source model with the task of detecting how far away things are. You can see that well, at least it looks like there's some contrasting there. It's pretty good. And I'll get more into some results that we've got to share. But I basically wanted to start off by saying it's this new vision model from the company formerly known as Facebook, like the artist formerly known as Prince. And basically it's really good. So I'll tell you what's going on here. I had a moment in the last talk, and I realized I've been talking for up to the voice is starting to
Mid-range.
yeah, but we're almost there. We've got the download almost there. So I had a moment where I was pointing to a graph of increasing data, giving you increasing performance. And this is a graph that's exactly like that. It's not as clear cut. You can see that what we have here is the number of flops, which a computer scientist would say is like the number of computations, and operations per second, floating operations per second. And basically, this is the accuracy of various tasks. So you have segmentation, you have monocular depth, classification. I just showed you a depth demo from this system, and basically video understanding. I mean, this is, remember I mentioned scene understanding to make microclimate inferences. Video understanding is a broad area that could be anything you want it to be. So any kind of inference that you think would show up in the pixels from the raw vision problems that you would encounter, you can train an AI to do it. And look at this. Look at this. That is very exciting, because what we have here is that if you just these are actually different models. So Meta released 4 different models, which is why everyone has a blue 4 triangles. And you get to see as the model gets bigger, what happens. I guess sometimes that one didn't work so well, but mostly this is what we see. By the way, sometimes better is slower. So that's why that one goes down for these metrics, basically. What I'm really getting at here, and I just want to make sure it's totally understood, because I think we all, from general AI perspective, should totally capture this point. The models are going to get bigger. The data sets are going to get bigger because the researchers are seeing this. They're seeing that, holy smokes, this model, this biggest model, is a 1.1 billion parameter model. So Howard mentioned 100. The human brain has 100 billion neurons. But right now, the best that Meta is going to at least release to us is a 1.1 billion model. I think Google's been training they claim to have trained the largest LLM, large language model. Recently, I don't know what the number is.
Less than $1 trillion.
It was $1 trillion?
GPT.
Okay, we'll have to get the numbers correct here. But you can see if it's a trillion, what happens? You know, what happens to the performance? And I just want to emphasize that because, okay, yeah, these big tech companies have it. I'm not gonna make any political points. But okay, so I want you to see that. Okay, so just, okay, the only thing I wanted to do here, I probably won't spend time on it, I just think it's not the right audience, but if you're interested, this is basically the architecture that is both the existing architecture for it and edits that I've made to it to build our plant AI system. I just wanted to point out this augmentation where you're forcing it to see many images. It's not really that interesting if you're not an AI developer. But basically, the cool thing that is relevant to point out is that I added these two components here. So this is a geo encoder. You hand it a GPS coordinate, which has, in this case, 3. I should have bolded that little 3 there, because what we do is we project the GPS coordinate to a spherical point, following someone else's approach. Basically, the deep network is able to capture knowledge of geography. And we combine that with all of this visual knowledge that comes out. So I wanted you to just roughly see that this is basically a big pipeline of processes that get chained through, and it comes from top to bottom. And basically at the bottom here of the network from Meta, the main thing is basically, I'm going to skip back for a second, that I want you to know, this network was not only bigger, but it was trained on more images. So this is a thing that Meta has made open source. You can use it. And I can tell you, I've been seeing spectacular results for completely unrelated applications that are based on the fact that Meta showed this AI system 140 million images, which is far more than any of you or I or all of us together combined will ever see in terms of the number of frames of real life that we'll ever see. So it's just, you know, it's spectacular that we all get access to this, and you can use it for any application that you want. And basically, we've customized it to build, I think it's going to be state of the art plant AI classifier and localizer and 3D reconstructor. It's going to pinpoint exactly where plants are in 3D from photos that you see, using the monocular depth and stuff like that that I've shown you. So you can see at the bottom here, this little output, that's 33,701. That's the number of species that we classify in. So just want you to kind of see how it all comes together. This might be the first time someone's ever shown you kind of an AI diagram, whatever, but you know, it's neat to know that it's not really a black box. You got a sense of how it all connects together. So anyways, yeah, we got geoencoder, and last but not least, some results. So basically, this is a walk in the park. I think you guys wouldn't even need to look at you know, the ground truth that's up there. That's not even ground truth, it's the AI prediction, but you know, that's lavender. This is like a sanity check. Can my system detect lavender? Ironically, the first batch of training couldn't, and I was like, oh, I got a problem. I had to go back. This is really cool. So this is a photo of the highline. It was used for the poster for like this workshop. And basically, what we have here is many plants. This is another P2 Dolph garden. And I ran it through the classifier as it's currently trained. The system is not perfect. I know for a fact that when I hold out test data, it's getting about 80% accuracy after training for 5 days on my 1 GPU. Again, please give me compute because I will improve that number. I can see the number going up. I just need more compute. So basically, yeah, when we run this on this system as it currently is, everything in green is a correct full species or genus. Actually, I forgot to finish highlighting this Veronica Strump, because I remember thinking I got half of them. This one, it should be in green as well. And how do I know? Basically, there's a plant list for the highline that you can visit there. And right now, you just see the classification, which might be enough to be useful. We're going to also pinpoint the exact location of what it's classifying per species as well. And then basically, this is not going to be a finished diagram. I was literally working on this when I got, started the talk. But basically, I wanted to at least show you what we've got. And basically, having a system that approximately sees that these different species, if you think of the colors as different species and planted different, ways, having a system that sees approximately, with enough signal of being true, where the species are planted roughly relative to each other. Maybe root structures are known to be good, and that's why they're planted that way. At the end of it, I think basically combined with this other constraints of like knowing that these plants will or will not grow well in your location, making inferences about your microclimate, and last but not least, being able Well, yeah, basically that will give you the system to generate. I think we'll be able to train a system to generate gardens. Basically garden designs that look exactly like real gardens. And then we'll render that in 3D, and extended reality. And that's basically it. So this is where we stop.
Marathon.
Yeah.
Well, I didn't think we use all 4 hours, but I can see that stuff.